Alrighty. So what we did last time was we went over the quizzes assignment. So this is what we did yesterday, and we got to the point where a bunch of people they're good up until this point, like series and parallel and all the general electricity stuff. But where we were having issues was down here with the actual questions. So what I want to discuss today is I'm going to give you guys some very basic electricity equations. And what I'll also do is I will give you the algebraic, I'll have the expression solved algebraically for the other variables too. So we're going to start with this first one here. So number 13. So if a battery produces 12.6 volts, what would the current flow be for a 6 ohm resistor? All right, so Josh says 2.1 amps. Okay, so with this, before we even start trying to figure out what equation to use, let's do what we normally do. We write down our knowns, write down our find, and then I'm going to give you guys an equation. So that's our find. All right. So if a battery produces this many volts, what would the current flow be for a 6 ohm resistor? All right, so the current flow. Current is going to be represented by the letter I. So I is current. And that's what we're trying to find in this particular problem. And this is going to have units of amps. Messy. Cool. So that's our find. How many amps is going to be going through this circuit? And then we have 12.6 volts. So 12.6, and volts is a capital V. And the variable that goes with volts, that represents volts, is a capital V. Okay. And then 6 ohms. So ohms is the unit for resistance. So 6, and then the symbol for ohms is the Greek symbol omega. All right, and this is resistance. So we have 2 knowns, and we have 1 unknown. Are we tracking so far? So the equation, I'm going to give you guys the 3 main ones that we're going to be using. So I would highly recommend that you guys write these down. So the first one is going to be V equals I times R. All right. So you guys may have seen this equation before. V is voltage. I is current. That's going to be in amps. Let me do that. I'll do the amps in different color. And then R is, of course, resistance. And then, so we're going to have V for voltage, capital A for amps, and then an ohm volts, amps, and ohms. So that's the first equation. The second one, numero dos, is going to be the power equation. And there's two different versions of this. The first one is going to be P is equal to I times V, where P is power. And the units for power will be watts. So that's a capital W. That's two T's. And then the I is current and the V is voltage. Now the second iteration of this one, power is also equal to I squared times R. So P is power, I is current, R is resistance. Cool. So those are the three main equations. They're very, very simple. And then I may just provide you guys a document. Like, I'm pretty sure that you guys, being honor students, can solve these three equations for any of the variables that are required. So I'll just leave this here. So if you guys want to, you can go ahead and take a screenshot for now. Okay. So which equation should I use out of these three to solve our problem? We need to find I. So every single one of these has I. So right now we can choose any of them, but I only have V and R as my knowns. So V, R, good. I don't know P, so it's not going to be these two. So I must use the top one. Okay. So V equals I times R. I'm asked to solve for I. So I want to solve for this bad boy. Hopefully you guys understand how I can solve for that. Don't need to explain how I get this. Hopefully not. All right, and then I know V, I know R. My voltage was 12.6. And then my resistance was 6. That's going to be ohms. And then this is going to be volts. And just like Josh mentioned earlier, this is going to end up with giving us, was it 2.1? Yeah, 2.1. 2.1 amps. Pretty easy stuff. So go back over to the problem. So 2.1 amps is going to be letter A. Any questions so far? Is everybody tracking? Yes, I can. Let me know when you got that out, Alex. I'm hoping the audio is fine on YouTube. All right, thank you. All right, and then I'm going to select this. Delete. this one. Delete. Oh. Let's do this. Make life a little bit easier. Let's move it down. Whoop, there we go. All right. So this question says, what is the voltage needed to cause a 2 amp current flow? 2 amp current flow through a 10 ohm resistor. So voltage is what we're trying to find. So we're trying to find V, and that's going to, of course, be in units of volts. And we have my current of 2 amperes. So amps, like when I say the word amp, that's a short way of saying amperes, which is the proper name for it. And then we have a 10 ohm resistor. So R, it's 10 ohms. Sometimes my omegas look weird. I don't like how those are looking. There we go. All right. So I need to find V, and I have I and R. So if I look at my equations, well, look at that. V equals I times R. All right. So 2 times 10, and I get 20. Easy peasy. Anybody confused about that? Do I need to write it out? If I do, let me know. Going once, going twice. Sold. And again, you guys can go back and watch the live stream if you missed it. All right, number 15. What is the resistance? So I need to find R. And that's going to be in ohms. To cause a 20 amp current flow because of a 100 volt battery. So current is equal to 20 amps. And then my voltage is equal to 100 volts. So I need to solve for R. I have I and V. So I can't use these two because I don't know power. So we're going to still use that one. So V equals I times R. I'm solving for R. So we get R is equal to V over I. My voltage is 100 volts. My current is 20 amps. So 100 divided by 20, I get what? I know it's the morning, but thank you. Okay. Yes, 5. And because it's resistance, this is going to be 5 ohms. All right, so 5 ohms. There we go. And I'll have this up for just a second. 3, 2, 1. Okay. I'm going to kind of get this done before the period ends. It's okay, Malik. I know it's the morning. Go get some coffee. Okay, so what is the power of a 20 volt bulb with 5 amps running through it? So it's asking what is the power? Power is, let's see, does purple work better? Yeah, I like purple. All right, and that's going to be in units of watts. And actually, let's go with the thinner purple. That's better. All right, so power is in watts. You'll get someone here at tech. Okay. And I have 20 volts So that's my voltage, and then 5 amps. So voltage is equal to 20 volts. And then my current is equal to 5 amperes. All right, so I have voltage and current. Let's go back up to our equations. So voltage and current. I don't know resistance, so I can't use this one. And I don't know resistance here, so I can't use that one. So I'm going to have to use the P is equal to IV. All right. And I'm already trying to solve for P, and my equations are already got that set up. So I need to plug in the values. So voltage is 20 volts. And then my amps is 5. So 20 times 5 is, there we go. And it needs to be in units of watts, so 100 watts. What does Doc Brown say? 28 gigawatts. Can't remember the number he uses, but he says gigawatts as gigawatts. It's strange. Okay. Doc Brown from Back to the Future. Please tell me you guys know what Back to the Future is. If you don't know Back to the Future, I failed you. Okay, good. All right, so only 4 more. We can get this done. All right, what is the current? So we're looking for I. Well, looks like I might have failed you. Well, I might make it a homework assignment. How about that? What is the current? So we're looking for current. That's gonna be in amps. Through a 11 volt bulb. So voltage is equal to 11 volts with a power of 99 watts. All right, so power, voltage, and current. Power, voltage, and current. So we're still going to use this one. So P equals IV. I'm trying to solve for current. So I want this one, so I keep it stationary. I divide both sides by volts. So volts cancel. And then I end up with current equaling power over voltage. So 99 problems. It's your boy. All right, so 99 divided by 11, I get 9, and then it's supposed to be current, so we get 9 amperes. And that's going to be numero B. Cool. What is the voltage? I'm going a little bit quicker now because time is fleeting. But hopefully this is not too intensive for you guys. So what is the voltage? So V equals, I don't know. To cause a 50 amp current. So current is I, 50 amps through a 10 ohm resistor. So R is equal to 10 ohms. So that's a V equals IR equation. Here are these guys. So V equals I times R. I'm already solved for voltage, so I just literally need to plug in. So it's going to be 50 times 10, and that will give us a whopping what? 500 volts. So it's not that one, not that one. 500 volts. I want to get a secondary like Stream Deck that is just populated with memes. So I can like push the button and then you'd be like Dora the Explorer, like celebrating and stuff, and you guys get the question right. I think that would be funny. Okay, so if a battery produces 12.6 volts, so that's voltage, so 12.6 volts. What would be the current? So we're looking for current. That's in amps of a 6 ohm resistor. Resistance is 6 ohms. So it's a VIR, so V equals IR. Same kind of problem. I'm solving for current now. So current is equal to V divided by R. My voltage is 12.6. I get 6. That should be 2 point something. Is it 2.1 or 2.4? My calculator on me. 2.1. Okay. Thank you. All right, so 2.1 amps. And then last but not least, what would the circuit resistance of a 7.5 amp, so circuit resistance, I'm looking for R. That's going to be in ohms. And then I'm given my current of 7.5 amps. Charging system with 15 volts. 15 volts. All right, so it's a V equals IR. This time I am solving for resistance. So I end up with R equals V over I. My voltage is 15. My I is 7.5. 15 divided by 7.5 is 2. So 2 ohms. Cool. So what do you guys think? Pretty easy stuff, right? It's super easy. Easy peasy lemon squeezy. Okay. So to go back to here, what I plan on doing is like solving this equation for I and R, and then I'll have all 3 of those in a little section, solve this one for I and V, and then likewise I and R. So there'll be a total of 9 equations from these 3, or including these 3. So that way you guys won't have to do the algebra. And that way, just like with the, I think it was the energy assessment that we did, where you would just need to find out use the find when we do this part here. So you just look for one of the equations that starts with that, and then on the other side has these, just to make your life super easy. Now, with these equations, it's probably redundant for me to do it, but I just want to be consistent because I've done that in the past, and I want to give everybody the best opportunity to do well. So I'm not here to grade you on your algebra. I'm here to make sure that you can read the word problem, extract the information, and then utilize the right equation. Cool. All right. So on that note, I will try to assign that quizzes thing again. And I'll shuffle the answers, but I'm going to kind of have this kind of format where you'll have these problems, but I'll set it up just like in the past where in Canvas, it will have a range of values to put in for the variables. So everybody can have different numbers, but every time that you attempt that quiz or assignment, it'll give you new values. So you can just do it unlimited amount of times for practice. I think that would be pretty useful, especially for easy equations like this. All right. Anybody have any questions, comments, concerns, criticisms? Only a few more weeks, guys. We got this. All right. So on that note, that's all I've got for you guys today. And I'll try to, for tomorrow, what I will do is, actually, instead of assigning the thing on, stressing about your vaccine, you'll be fine, Jeffrey. So instead of doing assigning the quizzes thing, I'm going to make a Canvas assignment. That way it's more catered to what we're doing. All right. I'll see you guys bright and early tomorrow. Have a great afternoon or great day. I don't know. Still early. Take it easy, guys. All right. You too, Makai.